Life as we know right now, impossible on Mars. But what if Mars were more like Earth? The now former chief scientist at NASA, James Green, says it could be possible to terraform Mars, meaning make it livable for people, which of course conjures up scenes from The Martian when Matt Damon's character, a botanist, gets stuck on Mars and has to figure out how to survive.
Cement is kind of the glue that holds concrete together. And concrete is used more than any other material on the planet other than water.
Since the beginning of time, human has been dreaming about exploring the sky. Nothing can stop man's imagination, which is ignited by their non-stop curiosity. We believe our imagination is unlimited as space is, and our will to act is much greater.
It's one small step for man, one giant leap for mankind.
We have a restless keenness that suits us as a human, which has been the motivation to continue space flights and to put our imprint and influence there. Now, man has gone past invading space and has been thinking hard to find a possible way that enables them in the future to live on Mars by establishing settlements there. This idea, rather than just providing long-term housing for astronauts, is also intended to enable future generations to travel and settle on Mars.
For humans to survive, a habitat is needed to protect from these extreme conditions, including temperature swings and the dangerous solar and cosmic radiation, which appears due to Mars' lack of magnetosphere. But could the conventional concrete be used to build these settlements?
The greatest challenge for achieving this dream is the providence of basic constructing materials. Using traditional construction materials is somehow impossible on Mars due to the absence of water and cement. Transporting these materials to Mars is unimaginably expensive. Besides, Portland cement paste cannot crystallize the same way as it does on Earth. Therefore, it was a must for us to think of a practical and affordable solution to overcome this challenge.
The proper solution is waterless cementless concrete, a new type of concrete that requires neither cement nor water. The question arises, what are the indigenous materials that can be used to produce cementless waterless concrete? The race began, and scientists investigated deep in the planet components. The scientific trips to Mars and samples obtained by rovers came with the results that sulfur is abundant on Mars. It has been found out that this material had the desired features to play an important role in binding the concrete ingredients for Mars construction.
Many fingers point to a material that could be conceivably made once we get to Mars. Martian concrete does not require water, and it consists of thermoplastic materials that could reverse its curing process. Thermoplastic could be reheated, remelted, and redeposited. It also gains strength in a very short time when compared to conventional Portland cement concrete.
Sulfur is presented on Mars in trilite soil. It can be extracted from Mars soil by heating it in a vacuum environment, resulting in the release of sulfur in the form of SO2 and H2S. Sulfur is generally expected to melt at about 119 Celsius and stiffen at above 148 Celsius. Therefore, the sulfur and aggregate must be mixed and heated at a temperature between 130 and 140 Celsius.
The ACI student chapter at Yarmouk University has implemented samples of Martian concrete in the lab by melting sulfur and adding aggregate. A quick hardening of sample was noticed that would make this mixture completely appropriate for the 3D printer. The samples were then melted to make sure that concrete is fully recyclable. Based on our experience, we can say that Martian concrete can be considered as a perfect solution for building a habitat on Mars. Research indicates that the mechanical properties of sulfur concrete are much higher than those of Portland cement concrete. The compressive strength could reach up to 50 megapascal. Furthermore, sulfur concrete was reported to have high resistance against energy radiation. Thus, it protects astronauts. Given the fact that the radiation intensity is about 5,000 times more than what a human could be exposed to during their life. Moreover, the absence of water in the sulfur concrete was found to increase its resistance to the damage caused by the repeated cycles of freezing and thawing.
Remarkably, there is no need for human involvement in the construction process. A small step for 3D printers, a giant leap for humankind. The essential feature of using the 3D printing technology is the short set period of sulfur concrete. Since time is critical in space, the shelter must be built quickly. The 3D printer using sulfur concrete could be the solution. How humans could be able to build settlements on Mars.
As the planet's oxygen levels would make it impossible for humans to build without spacesuits, oxygen devices, and life support machines, a team of semi-autonomous robots programmed with 3D printing technology are suggested for constructing a livable habitat on Mars.
The distance between the idea of sending a manned expedition to Mars and the reality of executing such a feat is shrinking dramatically. Finally, using sulfur concrete provides a necessary solution for construction materials with the desired mechanical properties and durability characteristics. In addition, sulfur concrete is environmentally friendly compared to Earth's concrete. As we know, concrete manufacturing is the third largest source of CO2 emissions. This implies that any sulfur concrete will be practically reusable without causing the same toll on Mars as it does on Earth.